Another aspect of time that folks sometimes forget about is that we can essentially throw time back to the start. The soil that has the thicker topsoil is a soil that has not been disturbed. Okay, so it has been forming in place. The soil next to it has been disturbed. It has been plowed, it has been worked, and you can see how that soil has kind of started back again. It's a little bit younger. It doesn't have the same profile or the same horizons in it that the older one has. So we can, by construction, farming, etc., kind of change that whole aspect of time in our soils. All right, so we've covered the factors of formation. It will be good now to just kind of take a few minutes and talk about the soil profile. What does a soil look like? And just some of the very basics, few minutes on the basics of a soil description. All right, so if you look at a soil, what do you see? And I usually, again, asking folks, what is the first thing that you notice? One of the first things is color. The colors change, and that's good. That's what we want you to see. The topsoil, 4 inches, 8 inches or so, is dark due to an accumulation of organic material. It's not an organic layer per se, but it does have a little bit of organic matter in the topsoil. The next down is where it is lighter in color. That is a leached zone. So iron, aluminum, organic matter, and particularly clay have been removed from that area as water percolates through it and moves down into the subsoil. The lighter orange material is kind of where a lot of that clay has kind of come out of the water moving. It's kind of been filtered out and is accumulating there. So that is our subsoil. As we move further down, we can see the color change again, and before it gets really orange, you can see how it's starting to get a little bit gray. And if you looked really close here, you would see that there are gray mottles or gray redoxomorphic features there. That indicates where the water table is. A little deeper below that, it gets red again. That is simply the parent material. Okay? So the material that this soil has developed from. So over time, this soil has changed. It's inherited its properties from the parent material as well as from the other factors. The organisms, where it is in the landscape, and so forth. So if we look at a soil profile, there are names for these horizons. Now, soil scientists are relatively simple, and what we did is realize many years ago that these layers in the soil were parallel to the ground surface. Knowing that the horizon is also parallel to the ground surface, the early soil scientists simply called all these layers horizons. Now, each one does have a designation. The very surface here is called an O horizon. An O horizon is simply that which has a lot of organic matter, greater than 12% organic carbon or 20% organic matter. You probably won't remember that, but what you will remember is that when you take an organic horizon and squeeze it, it oozes. It doesn't have a lot of weight. It may feel slightly greasy. That's an O horizon. We see most of our soils in the state that have O horizons are going to be in wet areas and in the coastal plain. We don't see too many in the Piedmont that have good O horizons, other than the little bit of litter, the leaf litter that falls and sticks around for a year or so. So that's also an O horizon, but it's not very decomposed. The true thick O horizons that we see in the Blacklands are very decomposed. They're called muck. The next horizon down is the A horizon. This is a horizon that is a mineral horizon, even though it's still dark in color. Rule of thumb, if you see a dark surface, don't call it an O, call it an A first, until you feel it. And if it feels greasy, then call it an O. But think A rather than O at this point. So an A horizon is the topsoil. Has some little bit of organic matter in there that's coloring it, giving it that blackish color. Okay? Below that is the E horizon. Now the E horizon stands for eluviation. And if you can't remember that, that's okay. Think of E for exit. Something has exited that horizon. What usually leaves it or exits it is clay, iron, aluminum, and organic matter. So again, the E horizon is a zone of eluviation or a zone where stuff has exited from it. It's a zone of leaching. Below that is the B horizon. Okay, and this is the subsoil. The B horizon is a zone of accumulation. It is a horizon which material has moved into. Now, if the E horizon is eluvial with an E, the B horizon, where stuff has moved into begins with an I, the B horizon is the illuvial horizon with an I. So material's moved into it and has accumulated. Usually you can tell the difference if you're able to feel them. The E horizon will feel sandier than the B horizon. So you get a little bit within each hand, squeeze it, kind of close your eyes, and you can feel the difference. The E horizon will feel sandier than the B horizon. The B will have a little bit more body to it, a little bit more stickiness from that extra clay that's present. Now the B horizon then eventually can move into the C horizon. The C horizon is the material that is the parent material, or that which is very similar to the parent material that this soil has developed from. It shows little soil development, generally very little soil structure, may still show some color, but it looks more like the stuff that this entire profile from O to B developed from, and doesn't exhibit the same features that you'd see in a B, E, or A horizon. Below that is the R horizon. The R horizon being the kind of the last that we can hit with the backhoe. Generally, when we hit an R horizon, we stop. That's when the geologists take over. If we can't dig through it, it'll prevent us from augering, from digging, from using a backhoe, etc. So that is the bedrock. Now, all of these horizons that we've shown from O to R sounds great, looks beautiful on this diagram. But in reality, we don't always, I should say, see all of them present. So don't assume that when you look at a soil profile that you're going to see every horizon present. You may only see 2 or 3, okay? Oftentimes, with because the Southeast and North Carolina, the soils are very weathered, it may be several feet before we hit a C horizon. In some cases, it may be 6, 8, 10 feet before we hit the C horizon. So don't automatically assume it's going to be there. And as I said, don't also assume that in the Piedmont you're going to have an O horizon. You probably won't. It'll probably be an A horizon. So again, look at the profile and try to figure out what horizons are there. Think of the processes that could have gone on, the factors of formation that made that soil look the way that it does. Okay? So there is a good way to remember the horizons. If you can't remember O, A, E, B, C, remember the mnemonic. Our Aunt Ethel bakes cookies regularly. That's one way to remember the horizons. And if you don't have an Aunt Ethel, Aunt Edna would work fine, Elizabeth, whatever. So our Aunt Ethel bakes cookies regularly is a good way to remember kind of what the horizons are. Okay, so again, looking at this profile, can you name the horizons? We've got an A horizon at the top from about 8 to 24 inches. That is an E horizon. From 24 to approximately, looks like about 30 inches is our upper B horizon. 30 to, I think, about 60 inches, 48 inches, somewhere in that range, is our lower B. And then from that point on is our C horizon. We can also have transitional horizons where you're not quite sure whether it's an A or a B. So you call it an AB, capital A, capital B. That's a transition. It's because Mother Nature doesn't always paint with a very fine brush. Mother Nature uses a very wide brush. So sometimes we've got to use a transition and talk about things changing slowly, not very quickly in the soil profile. So a transitional horizon is perfectly fine if you're not sure. But remember, O, A, EBCR. Our Aunt Ethel bakes cookies regularly, and hopefully you'll remember the horizons. Okay, with that, you can ask questions if there was an audience here, or email me, contact the museum for additional questions.